We are going to discuss the details of dictionaries in this section. As you would recall that dictionaries are special forms of sets. Some operations and functions apply both dictionaries and sets. So as you would all remember that sets are collections of unique items. There cannot be any duplicate values in a set. Similarly, dictionaries cannot contain duplicate keys in their containers. However, the values can be replicated among other keys. We have the keys method for the dictionary in our example. So we first create this dictionary of bank account balances maybe, or the points accumulated in a game. For each person, so this is a string corresponding to a person name, and a value, a numerical value corresponding to a balance amount. In this first print statement, we have an entry, a value entry retrieved from the balance dictionary. So you should go back to this string formatting section and check what this percentage notation is, how it's going to be output using this percentage inside a string template and the formatting operator again as the percentage symbol. Now from this balance dictionary we use a function, a method named get. It is similar to the access operator that we use to retrieve a value corresponding to the key Alice. Okay, it's going to retrieve this number for us. So when we have the output, let's just comment this part and go step by step. And if we execute this example, Alice has some units of balance output to the display, where it is formatted according to this template, which it's going to reserve 10 spaces and 2 spaces for the fractional part or decimal part, and the total area is going to be 10 characters long. So there are going to be 7 spaces reserved for the whole part, integer part of the number, where it's going to align the output as much as 3 spaces before the number, because it consists of 4 digits. And after that line, we have a modification in our dictionary where we reset the balance of Alice to 3,500 units. And then we can iterate over each key in the balance dictionary using the keys function. As in this case, the keys method is going to return Alice, Claire, and Spider-Man in our dictionary, and we can now iterate over those values as the key variable. So balance of, this is the first template area, formatting template area, and this is the second template area. So it's an S template, meaning that there's going to be a string that is going to be formatted as 10 characters long. and the second format area is a floating point number area, which we are going to retrieve from the dictionary. And printing this line, now if we have the key as Claire, so we are iterating over the keys. First we might encounter Alice, but the order is not guaranteed, as I mentioned in the earlier lectures. Claire may appear as the first or the last or the second key, depending on the current state of our dictionary. So if the key is Claire, we want to update its value to 25,000. Okay, and then after that modification, we are going to see that the balance has been modified. So accessing the value either using the access operator or the get method have the same effect. They are equal in terms of output. And if we execute the code up to this line, we're going to see that the balance of Alice is 3,500 because we have updated this or overwritten that part, and the first print is the first Alice part and the second print is the second Alice part. When it comes to Claire, it first outputs the current value, which is 15,000. Okay, and as the key is equal to Claire, it has updated the current value to 25,000, and the second print outputs this result. And for Spider-Man, we have no change. We have no modification in our code. And in the remaining parts of the examples, we have the view method. Let's ignore this part first. We have the view method. That returns a special output that is generated as a view. Okay, let's comment this part out as well. Now let's execute this part. Okay, a view is a special object, a special entity that you can obtain as dict items from your dictionary, such as when you want to access the view, you will receive such an output. Let's move to the beginning. So we have this dictionary again. We don't modify the values, same output. And now I have this special variable, which is the balanced dict dot items method. Its type is dict items, useful in advanced topics. And then if you print dict items, it's going to be outputting these results as their current values all together as tuples. When you update the dictionary, a specific key with some value, you don't need to obtain the view. So it says it's something generated for you that you can always access. So it's in your memory, in your computer memory. So there is this variable of dict items, okay, the items pointed by this item view variable, and it's a mirror image of this balanced dictionary, that when you modify it, when you modify the dictionary itself, the view is all automatically updated because it's pointing to this position. It's not something we use in this course, but that feature is useful in some advanced areas of Python programming language. So you might want to keep that in mind in case you want to work on Python projects or either in your academic careers or professional careers. So academic career is also a professional career. So in either cases, you might find it useful. Just an extra implementation. There's something called dict items or a view that you can obtain using the items method. Okay. Well, we have discussed the in operator, which checks whether something is present inside a collection or not. When you use it with the if statement, let's experiment on this example. When you use it inside an if statement along with a dictionary, it's going to check whether this variable or string or number is in the keys part of the dictionary. Okay, it's not going to check value part, it's going to check whether account owner is among the keys of this dictionary. Let's see, display balance, and let's see if Batman has an account in our bank. Batman does not have an account because we make a check whether this account owner is present among our dictionary keys. As Batman does not have an account, we display this message using the string formatting operator. And if somebody has a balance, we just output their name and their balance in the screen. Okay, I think this is end of this presentation. So there are some methods other than keys, items, get, that you can use along with dictionaries. The pop method simply removes a key and its value from the dictionary. As in this example, we have Spider-Man that we want to pop. So let's just print our balanced dictionary before we make a modification. Print balanced dictionary. Okay. Print removed Spider-Man. Print del deleted Claire. Okay, and let's execute this. And let's also pop Batman, print balance dictionary. And when we run this example, before jumping to the error, we have this initial version, Alice, Claire, Joker, and Batman. So we have output this line at this statement, and then we popped Spider-Man. Okay, and our dictionary becomes Alice, Claire, and Joker without the Spider-Man and its value. So a value cannot exist without a key. So its value part is also removed from our dictionary. Also, we can use the del keyword, del operator, to remove a key and its value. So we have deleted Claire at this line. Now we are left with Alice and Joker. However, if you want to pop Batman from our dictionary, it's going to raise an error. There is no such thing as Batman in your dictionary, and your program simply crashes. So in order to prevent such crashing misbehavior, you can simply check whether this value is present. So item to remove equals Batman. For instance, you might receive it in a function as a parameter. If item to remove in balance dictionary or balance dictionary.keys, then you can simply try to remove the item to remove, which is Batman in our case. Else, you might want to introduce an else part. Item to remove does not exist. Okay, so you can simply output something like this. And if you execute your code is not going to crash. Instead, it's going to output a result. You can also use try and except if it's raising an error exception, and return to user accordingly. And now we have the same dictionary where we used pop and del operations in the same example. You can also use the clear method, to remove all items from your dictionary. But when you initiate your dictionary, it is reserved at a memory location like this, containing key 1, value 1 pairs. Okay, like this. When you run the clear operation, value 2, it's going to remove all these entries from your dictionary, but it's going to keep that dictionary in this memory location without anything inside it. So the reference is going to hold. It's not going to be deleted if you don't execute the delete operation as del balance dictionary. If you say del balance dictionary, it's going to remove that variable, and you will not be able to access those elements unless you have another reference to the dictionary itself. So let's see this on the move. This is another example. So when we run this, we see that we have our dictionary output like this. So this is our balanced dictionary. We execute the clear method, and then when we execute this, we can still access the balanced dictionary, but it's empty due to the clear method. When we delete the balanced dictionary, we can no longer access that variable because it's removed from the access stack of or the memory space of the interpreter. So when you call del on any variable, it's just removed from the memory. It could be pointing to some other location, as in this case. These will stay in memory as long as it is referred by another variable, another container, another item. But if there is no such reference left, the garbage collector is going to reclaim this space for using in another statement, for using for other maybe larger, maybe smaller containers or variables. So memory management is very important. If something has no references left pointing to this direction, pointing to this memory space, they are all going to be removed. It stays as an orphan, and this memory space is going to be cleared up by the garbage collector as soon as the memory used by the program reaches to some threshold, or depending on the implementation of the garbage collector, it's going to invoke at some intervals, maybe periodical, maybe depending on the current processing capacity of the program. If the program is idle up to some extent, the garbage collector may start collecting these areas consumed by other older data, which is no longer accessible from inside that computer program, because there are no references left to this position. We have lost them all. We have deleted them all. Maybe we started that reference, we initiated that reference inside a local scope, and that scope is gone. So the data is in the memory, but you cannot access that. So it can be reclaimed by the garbage collector. Okay. So you can use the remove function, remove method from on a set or a dictionary. If you execute that, let's first see the remove, and then we're going to so if you run remove, you have to specify a value. Okay, specify this value. It's going to remove Joker from our set. This would work on a dictionary as well, and it's always going to remove that item if it is present. If it is not present, because it's been removed already, let's duplicate this line and try to remove something already removed or not present. It's going to raise an error because Joker has already been removed at this line, so you cannot re-remove it. Okay, it just simply doesn't allow you to proceed. If you remove it, it's gone. But if you use the pop, students.pop on a set, it's going to remove a random item from the set. As the set does not have an ordering, and pop by definition is something like this. Clear this once again. As you would remember, this is a stack. You push items onto a stack, push, so they go from bottom up. When you call pop, it's going to remove the latest item inserted on your stack, if this is a stack. But in case of sets, we don't have such an ordering, so it's going to remove the first item that is retrieved by the get function, or retrieved by the internal function that returns values when you execute the pop function. So as you would recall, we had colors like this in a set: yellow, black, magenta, or yellow, white, magenta. Each time we assign those sets to string, to lists, using the list constructor, it would give a different ordering like this: blue, yellow, magenta, magenta, yellow, blue, etc. So there is no specific ordering in sets. And in this case, using the pop method, it's going to be removing a random value from your set, seemingly random. It's not actually using the random library, but depending on the current state of your set, which might have hundreds of components, it's going to remove something not in the order you have provided them. So when you remove, it has removed the we have already removed Joker. So let's just forget about this remove function and see what it pops. And this is just a comment. So it has removed Claire in this execution. It has removed Spider-Man in this other execution. So there's no guarantee that it's going to pop the latest item that you inserted in your dictionary or set. There's that method allowed, but the result is not deterministic. You cannot say that it's going to remove the last element inserted to a list or a dictionary. Okay, we have discussed this in operator that can be applied on dictionaries, also that can be applied to sets as well. If something is present in a dictionary, so let's first display all account names in the balanced dictionary. So for loop is going to iterate over those items using the in operator, assign them one by one to as account names. So Alice, Claire, Joker, Spider-Man are going to be the account names at each iteration. And this has the similar effect. So these two for loops have identical outcomes. If you omit the keys, it's still going to check among the keys, because keys are the set, the unique elements of the dictionary. You can also iterate over the values in your dictionary other than the keys. So let's run this and see the result. So it's first outputting all the keys and repeating that in the second loop. And in the third for loop, we have the values being iterated by the for loop. Instead of the keys or the dictionary itself, it's going to use the values method of the dictionary. You don't have a values method in a set. It's a method of the dictionary. And it's going to simply output that result, as in this case. Also, you can iterate over the tuples that are returned by the view. the items method. As you would recall, it was returning the special variable dict items, and in that dict items you had tuples corresponding to each key value pair. So you can obtain those keys and values as tuples if you need them, using the items or the view functionality of the dictionary. So this is, you can also generate your own key value pairs, but if you need them as tuples, as ready-made tuples, you can use the items iterator, and you can use this items iterator to assign those values retrieved as first parameter to be the value returned by the items, and the second to be the corresponding value. So we had something like this: Spider-Man has some great amount of money. Okay, it's going to assign as Spider-Man as the account name, and the balance to the balance variable, because they are specified in such an order. The first one receives the first part, second one receives the second part, returned by the items collection. Okay, I think we are done with this. And one last slide that we have here is we can make copies. We can make copies of dictionaries as long as they are primitive types. We're going to soon see. Now we have this students dictionary where we insert Batman as a new student. I don't know what type of school that is. And this one is already passed as a reference to students. It's also going to be containing Batman. Okay, so this was the initial version containing the Batman entry. Okay, although we have inserted the Batman character to the students dictionary, as this students temp is also pointing to the same location, always drawing the same picture here. They are both pointing to the same place. Modifying one means modifying the other. And student temp, if we make this using the copy operation, they are no longer going to be pointing to the same location. So students is actually pointing to this location. When you use the copy function, copy method of students, it's going to be a replica of the original students dictionary, students, and this is temp. Okay, st temp. So they are in different locations in memory. When you insert into students, it contains the value, it contains this new person here, sorry, but the student's temp does not have this new value. Okay, you can also use the dict constructor. This is the constructor. It is going to generate a new dictionary in the memory. So this is students. Student temp is going to be a new dictionary at a different location. So copy and Dict are similar. Constructing from another dictionary or using the copy function has similar effects, that it generates a new entity, new dictionary at another location. So these two are not equal, they are different. They are different dictionaries, although they have the same elements stored in their memory space. Let's work on this further. So I want to remove let's remove the Batman from our students entry. Students.remove Batman. And if we want to output those, both of those dictionaries, we're going to see that students and student temp are different. Oops, sorry. Doesn't have remove, so that's my bad. Let me just delete it from the students. Delete it from student. Oops. Delete students Batman. Okay. Delete it from my dictionary and print students. Key error. I don't have a key as Batman because the key was wrong. Sorry. Once again, I should have specified Batman's student number instead of its name. Now it's going to remove that Batman from my students dictionary, but students temp is not affected from that because it was a copy of the original students dictionary. So this is the student dictionary containing Alice, Claire, Joker, Spider-Man, Batman, and it also contains Gida. And let's just print it out here before making a copy. Print some dashes and then print my students dictionary, and from there I make a copy of that dictionary using the dict constructor, which receives the other dictionary as an argument. And then from that initial list I remove the number of Batman, I print students, and I print students temp one after the other. So after the dash line I have my list containing Batman and Gida, from which I constructed a new one referred by students temp. Although I have removed Batman from the original list, which is output at this second line in the last group, it's reflected to this one, but my other list, my other dictionary is not affected from that removal, from that delete operation. And if we have something, let's say a complex type instead of primitive values, as we have tried in the lists. Sorry, I'm just thinking. So if we insert a list instead of a string, Batman, so we could delete it from the original. Okay, so we have this Robin as his assistant. Okay, this either may attend, so let's run this first. Let's go step by step. Batman and Robin. Okay, from that list, instead of deleting this entire set, now I'm only going to remove Robin from that list. Okay. Remove students.remove. I should call this now. This is a list, and I have a remove function, remove method that I can use on lists. Okay. Now what happened is my initial dictionary again in this memory space had these primitive entries. So it contained Alice. So 9001 corresponds to Alice. 9002 corresponds to Claire. Okay, they have 2000 each. And at a later step, I have inserted a record as 9005 to point to a list and not a primitive type. So this list is generated at some other location in the memory, okay, containing Batman and Robin. Now when I make a copy of students, or when I construct another dictionary using the dict constructor, all this information is copied to a new location in memory. Similarly, 9001 is Alice, and 9005, so 2000, 9005 is again a reference to the existing complex type, which is a list in this case. So if I remove Robin over this students, accessing that data from the students variable, students dictionary, I'm going to go to this list, remove Robin from there, and when I try to access it using the students temp, which was not this one, which was a copy of that one, when you want to access it, it's also going to go to the same memory location, and you will observe that there is no Robin in your output. So pass by reference and pass by value are two different and two very important procedures you should all be familiar with, and it works with all lists, tuples, sets, and dictionaries. And we have some further examples. where you can use tuples to lists of tuples to construct a dictionary. Okay, you can provide your input like this to a dictionary. It has to be a list of strings, list of tuples, sorry. So the constructor is going to output this result for you. Let me see. I have the working example here. Okay, and let's just move this part up. Let's just comment this part too so that we don't execute it. And run this example. So I had these tuples, a list of tuples. Alice. It looks similar to dict items returned by the items method of the dictionary, but in the opposite direction. So if you provide something like this to the constructor, dict constructor, it's going to give you this dictionary where you can see in the output, which you can see in the output. Also, you can retrieve the value of Michael, which is 19. Okay, you provide Michael as a key to your dictionary, proving that this has been constructed as a dictionary. And also the last item that we might visit in this example is that you can have composite keys consisting of multiple entries as a tuple in a dictionary. You can use tuples as keys to your values, but you cannot use lists as keys to your dictionary values, because lists can be modified and they cannot be hashed, or they are mutable. So when you write something like this, I have a key consisting of multiple items, which is going to be a tuple. You can have another item, Alice Morgan, McDonald. So I don't know how it's written, but you can have a composite key consisting of more than 2 items. It's also going to be a tuple, but the tuple, as you know, is a fixed item. It cannot be modified, so it can be used as a key. If something can be modified, it cannot be hashed in the same way to access the value, so it's not allowed. So let's try it like this. Balanced dictionary will output as composite keys, will generate the following error. And let's try this. Unhashable type list. So you cannot insert a value like this. This is the insertion part. When you assign something, when you assign a value to a key provided as a list, it cannot be hashed. Okay, this list cannot be used as a hash, but if you provided it as a tuple instead of a list like this, converting the key to a tuple and executing your code, you will have Claire Macmillan to have this value. We can also I don't know, again, Claire something else. Let's make it Claire Green. Okay, we don't have to have all American hierarchies. So let's run this. Now I have 2 different records. One I have provided without using the without using the tuple parentheses. Okay, although I have, where's my pen? Although I haven't specified it using the tuple parentheses, it automatically inserts that record as a tuple, as in this case. I can explicitly write the tuple parentheses, and it's also going to have the same effect, but I cannot input a list that is going to be used as the key to my dictionary. Okay, if you write it like this, as a list and not a tuple, it's going to raise that error that list cannot be hashed. So it means that although your list is preserved in the same location in memory, its contents may change. So when the dictionary is going to be accessing the values based on that list, it's going to check its contents as the key. You might have multiple lists in your memory. So this is your memory. This is your, again, so this is your memory space. You have a list which is empty. In another location, you might have another list which is also empty. Okay. So you can also have lists containing same values. Claire. Okay, Claire. There's another list at a different location containing the value Claire. Maybe same set of arguments, same set of items in the list. But these two are different lists. They are different instances. Whenever you provide this as a key to your dictionary, it cannot differentiate which list you are referring to. So it rejects to use lists as keys to dictionaries, but you can use tuples as keys, because whenever you have such a tuple, all other tuples generated as this single entry tuple are going to be pointing to the same location in memory, so it can be hashed. It's immutable, it cannot be modified, and it can be used as a key to the dictionary. Okay, this wraps up the entire content of our course this semester. We have 2 more chapters remaining, but they are for the students who are interested in further details of this course. I will cover them in the last lecture if I have time, but if I don't, you are not responsible of, if I do or don't, you are not responsible of chapters 7 and 8. And I think this is all for today. So see you next time.